guys. Um, but this is something I wanted to tell you guys. So please practice some of the problem from Young's double slit experiment as well as a single slit diffraction. Okay, that's on your own. I'm gonna do another problem here. So let's call this number 2. Just a moment. Okay, so orange light 662 nanometer in air. Please, you guys also start writing these questions, okay, as I'm writing, so we can start quickly. Signs on a soap film n equal to 1.33 that has air on either side. The light strikes the film perpendicularly what is the minimum thickness of the film for which constructive interference causes it to look bright in reflected light. Okay? So please finish writing this and try to solve this one. We did similar problem the other day, so please try to work on this, okay, on your own. So the answer is, for this is 124.4 nanometer. Okay, so make sure you get this, you solve this on your own. Okay, so please note down this answer and then see if you got that. Okay, this is problem 3. Okay, so the average and please start writing this question with me, okay, along with me. Distance between the
Sorry.
Excuse me guys, let me get you.
Sorry, I have to do this. You can edit it out if you have to. Sorry about that.
Sorry about that. Surface of the earth and the surface of the sun is 1.49 times 10 to the power 11 meter. How much time in minutes does it take for light leaving the surface of the sun to reach the earth? Okay guys, so finish copying this question and try to see if you can come up with the answer, okay? So try to work on this. Alright, did you guys get any answer for this? Did you solve this? Okay, so I'm gonna erase everything other than the things I need. Okay, so the average distance between the surface of the earth and the surface of the sun is this. So I would need that information. So let's make a sun here. I'm gonna make earth here. I mean, of course, that's the exaggerate. So the distance, this d is given to us, and then d. Okay, so so I'm gonna start writing here. Distance is what? 1.49 into 10 to the power 11 meter. Okay, so how much time in minutes does it take for light leaving the surface of the sun to reach the earth? So let's say sunlight leaves from here, so this kind of goes all the way here. Okay, so that's the ray. What is the time, right? Duration, really, delta t. What's the delta t taken? Duration taken by this, sunlight leaving the surface of the sun to reach to the surface of the earth. So distance d or delta t, right? So instead of delta t, let's say just t. I mean, you guys may be wondering, okay, why am I saying delta t? Delta t has to do with calculus, or let's leave it. Okay, the duration is t here. How long does it take for this light ray to reach to the surface of the earth from the surface of the sun, right? So what do we know? This is really simple, right? Or maybe not simple. What we know is, we know c is the speed of the light, right? C equal to what? 3 into 10 to the power 8 meter per second. So it takes 3 times 10 to the power 8 meter per second for light ray to to travel, right, in vacuum. That's the speed of the light in vacuum. And we know in between there is a vacuum, right? Like that, we have a space. Okay, so now what we want to do is, we have a speed. This is really same as our v, right? So this is like our speed v. So what we also know is b equal to what? Distance traveled d, right? Distance traveled by time taken t. So we are going to use this equation here for speed. So if you cross multiply, t goes up here, t equal to then d by v. But our v is this, okay? Speed of the light. So the distance is what? 1.49 times 10 to the power 11, and then b is what? B is our c, right? Speed of light. This c is just represented as c, so this is just 3 into 10 to the power 8. What value do you get here? So calculate this, please. So do you get 496.7 second? Okay, so this, but we are asked to find the information here, right? We are asked to find t equal to what in minutes. Okay, so that is what we need to find. Since we have a second, if you divide this by 60, that will give us the time in the minute, right? So therefore t in minutes equal to 496.7 divided by 60. This should give us about what? 8.3? 8.3 minutes, okay? So it takes about 8.3 minutes for a ray of sunlight to travel from the sun to the surface of the earth. So all the sun rays you get when it's shiny, sunshine outside, it has been traveling for about 8.3 minutes, okay, to hit you. Alright. Maybe a little bit less than that, because then you are above the surface of the earth, but that's negligible. Okay, so please go through this and then look at this per minute, this per